Hello learners, I hope you are preparing very well for your board examination. Today in this particular video, you will be learning that how do an examiner corrects your paper. In the previous class, I had given my students some of the number based programming questions which they have written and they have given me. And I will be checking each programs and I will be saying in which part of the program if you will be doing what type of error and where is usually your marks get cut. So let's start checking. First, let's understand the question that is mentioned over here. Here it has said that from number 1 to 1000, you need to find a number whose sum of all uh, divisors is equal to number. Here is the definition of the perfect number. So here the question is you need to check from 1 to 1000 how many numbers are the perfect number. And here is the definition. What's the definition? The definition is a number is said to be perfect number if you will be adding all its divisors and you will be getting the number itself. For example, here the example is 28. So 1 is divisible, 2 is divisible, 4, 7, 14, 28. And if you will be adding them up, the result that you are getting is 28. That is exactly the given number. Okay, so we will be doing same thing and let's see how the student has done. See, here actually, okay. So here he has written, he has imported java.util package, which I don't think was necessary here. Because here we are not accepting any number, right? So this was unnecessary part of this particular program. Public class perfect, correct. This is open. Main method is open. This is open. And scanner class. This was also unnecessary step because here we are not accepting any number from the user, as we need to calculate 1 to 1000 all the numbers which are perfect, and the logic for the perfect and the definition for the perfect number is already mentioned, so we do not need any scanner class over here. So here the student has taken 1 to 1000, which is of course the range, so this is correct. For this students will be getting the marks. And here what we need to do, we need to figure out the logic for the perfect number. For before finding the logic behind perfect number, what are we actually finding? We are finding the factors of the given number. See, I is the number, so here my I will be the one. And here with this particular loop, if you will be observing, the student has found all of the factors. Like if something is divisible with the given number, so what has he done? He had stored it. Not only stored, but he has found the sum of it. And for finding the sum of it, he has initialized s to be 0. That is perfectly correct, right? So here sum of all the factors will be stored, and as soon as it will be coming out of the inner loop, here it will be checking whether the sum that was found out from this particular process, is it equal to the number or not. If it is found to be equal to the number, then the perfect number is that particular number will be printed, which is absolutely correct. Then comes the else part. Let's see what he has done in the else part. If you will not be finding, if that number is not found to be perfect, then what had he done? He had written s is equal to 0 and continue. See, here I could find in an error. Here what happened? We need to keep this s is equal to 0 independently, because if there will be a place where we will be finding a number perfect, there also I need to make my s is equal to 0. So this needs to be kept independently, but here the student has kept it dependent with the else. This is correct. Okay, so where this has to be written? This has to be written after, just a moment, if is over, if condition is else. So I think the student would have not given this curly braces and has not put this into else while continue was okay. After this particular else part, the student should have written s is equal to 0. So what would have happened? Every time, if even whenever my number is found to be a perfect number, that perfect number will be printed. And whenever the number is not found to be perfect number, there also it has to be there also this has to be executed. But here what happened, due to the presence of continue, this particular cursor will be going to my I. So I think this is also not necessary. let's not write anything for the else. I would recommend, if you are ever facing this particular thing where you are asked to print the this perfect number or palindrome number from 1 to the even number, I would prefer do not write anything in the else part. See, if I'm finding a perfect number, then the perfect number will be printed. Then after this, s is equal to 0 will be executed. Even though my number will be not be found to be a perfect number, then also s is equal to 0. If my number is found to be perfect number, then also number will be printed and s is equal to 0. So this is independent, and this has to be independent, and you already know this why it has to be independent. So for this, small marks will be cut over there. So now let's see. So here he has closed the loop. This is main method and this is the class. Okay, so if examiner will be checking this, these two were two unnecessary statements. So for this, usually examiners do not cut the mark, they just do provide that this was the unnecessary step. But for this that I have cut down over here, here some of the marks will get reduced. So here you can expect in the board examination from 15, it will be on and around 10 to 12, because as here s is equal to 0 is only made when the number is found to be a perfect number. So in any other place wherever the number will not be found to be a perfect number, there this s will not become 0. This is the problem. So between 10 to 12, a student will be getting marks whenever somebody will be writing this program and has done this type of mistake. Now let us come to the another program. This is Karpikar number. Okay, a number whose square when splitted into the sum of its digit is said to be equal number. See, let's see, it has taken 45. So 45, if I will be finding out the square of 45, so it is 2025. Acha, and whenever 20 plus 25 is added, it is giving me 45. Acha, so here it is said the square of the number, if it's splitted into two parts, if it's splitted into two equal parts, so and when they are added, you will be getting the same number. It's a very good question actually. 45 is taken, 45. Okay, he has written also the algorithm what has to be done. Let's think about this. Okay, so first of all, the most important thing is I could find this particular question can only be formed whenever my number of digits has to be even. Because see, if I have taken 124, if I will be dividing this into two parts, do you think can we able to divide? No. But if a number is 14, we can divide it, and one part it will be 1, another part it will be 4. And if the number is 2025 as here, we have divided it equally. I think this question can only be formed, or we need to check the square of the number has to be has to contain even number of digits. Otherwise, while asking the user itself, we need to expect a user a particular number in such a way that the square has to be what used to be even number of digits. So let's see what the student has done. So here we need to accept a number from the user. So it's absolutely correct. We have written scan. We have introduced java.util, package is declared, class name, correct, scanner for accepting the number. Here this particular variable part you must be observing. I have also not observed very carefully in the previous program, because whenever I will be observing that the variable which are in use is declared properly, there the teacher will be giving perfect marks. See, here I am observing sqr, it is used n into n. Then I will be noticing whether somebody has declared the sqr or not. Yes, it is declared, so for that the marks are usually given. And here copy underscore n is equal to sqr. So the original number is stored by the student in another variable. Okay, and this particular variable is also declared, as you can see, int and int. Every variables are mentioned over here. Now let's see, the student has subdivided into two parts. Acha, so directly, very good. See, it's a very good way. If somebody is given 2045, if I will be dividing it with 100, so it will be what, 20. So 2000. Yes or no? So 45. Can you see my reminder is storing the other two digits, the last two digits, and my quotient is storing the previous two digits. So the student has done exactly the same thing and has added here s is equal s plus r. Okay, nice. And squr is equal sq divided by 100. So what is stored here? 20 is stored. Now when it is divided again with 100, zeros are 0, so 20. That means what? The remainder is storing r. So now what happened? At the next particular time, very correctly, the student has added other other part of the number, that is 20. Very correct, very correct. This is a very impressive kind of a logic that is used by the student. So here student will be getting a very good mark. So here the student has checked if s is equal to n. See, s is storing, just a moment, yes, what is this s storing? This s is storing whenever the square of the digits square of the number is found out and it is divided into two parts. Here what has done, the two parts are added and are stored here. So here it is exactly checking what has the question asked. So what is this s storing? The s is actually storing this. At first 20 is picked out, then 25 is picked out. S is storing actually this 45. And what is my n storing? N is my original number. N is the original number that has to be stored. But here I could find another problem in this particular program. If you will be observing this particular program, you will be saying that the student has not accepted the number from the user at all. Can you see? The scanner class object is created, the package is declared very properly, but here the student has not accepted any number from the user. That is 100% difficult task. See, n into n is done, but where is this n accepted? N is not accepted, so n has to be accepted. System not out or println. Otherwise, if you will be not getting a number from itself from the user, then how you will be doing all of this particular thing? So enter a number. So let me write only enter for this particular time, and I need to store the n. So let me use int n is equal to, otherwise as n is already declared, here, can you see I have double tick. So let me write n is equal to what's the scan object sc dot next in. So here what will happen? Here this is correct now. So n in the place of n, user has accepted the number. Now it is absolutely correct up to this. But for not accepting the number from 15, easily examiner can cut 3 to 4 marks, where he or she may give 10 to 12. 10 to 12 marks you can expect if you are not accepting a number. 10 is the least I could say, because as the logical part is correct, maximum marks you will be getting out of that. But see, only because of not accepting any number from the user, unnecessary your marks are cut here. Okay, now let's come to another part. Tech number. What is this tech number all about? A number with even number of digits, when split into two parts from middle, the parts added to the sums square is the work number, is the assigned number, is the original number. Okay, is the original number, I guess. Okay, let's see from the example. Whenever in the examination as well, if you are unable to understand anything from the statement, the best way is observe the example, and the example will be there 100% in your question paper. So see here, if a student, if a examiner has given, if a user has given me 3025 as a number, and here number of digits are 4, and it is split into two parts. Sum is equal to 55, okay. Square of this is 3025. Acha, very good question. You will be accepting a 4-digit number, and when you will be accepting, see, you will be a number with even number of digits. See, it will only be working in the question, because see, when you are dividing a number into two parts, there you can expect that the square of the number has to be even number of digits. Otherwise, neither this particular tech number will work, nor the previous question that we have done that will work, right? Let's see. So here it has to be, let's see whether this, so here mandatorily the student has to check whether the square of the number, whether the number that is accepted from the user, whether it is uneven, whether it is containing even number of digits or not. If the particular number is not containing even number of digits, my program has to stop over there. Let's see what the student has done. So here a number has to be accepted. So here java.util package is declared. Here the class, again the main method, absolutely correct, scanner class is declared. But I think user, the student has not written it correctly to accept the number from the user. Acha. But let's see. Okay, what is this n storing? Why is it so clumsy? That is written by the user, that is written by the student. Mm, see, many cuttings. This was the only thing that irritates. See, he has written many things here in a very complex manner. Copy n is equal to n is equal to, see, this is so mess. So here examiner may be irritated and will be just giving a minimum mark that could be given to a program without checking the whole of the program. So this program could have written very properly. See, what would have written after I will be accepting the number from the user. This is a very easy program and could have written very properly and very perfectly. Okay, so here system.out.println, I will be accepting a number. Let me write how this program could have written so that it would have been easily, you would have achieved a very good marks over here. So just a moment. Yeah, enter a number. Okay, and let me write num for this particular time. I will be storing first of all the number. See, very easy. Let me consider sc was the name of my object. Okay, now it's over. See, very beautifully we can just check it out. First check whether it is containing four number of digits or not. For checking whether a number is containing four digits number or not, you need to pick out its digits. So for picking out its digit, I will be just using a counter. So here what will I be doing? I will be initializing, I will be declaring a variable in this p. I will be just be storing, I will just be storing the remainder, which is of course of no use. Here I am only calculating the number of digits. So here I will be taking another variable. You could also follow some other steps, but I could find this one is the easiest one that any student could try. So here what will happen? As soon as this while loop will be completed, if you will be observing this, Z will be storing the number of digits. See, very easily and very fundamental steps are used over there to check whether that particular number is 4-digit number or not. So here I have taken a loop just to check whether the number of digits that are present are even number of digits or not. So here after this I will be checking and modulus 2 is equal to 0 or not. If I'm finding z, because z is storing the number of digits, if I'm finding it is even, then what will I be doing? I will be dividing it into two parts as in the previous case we had done. So let us do one thing, dear. Here let me store int n1 is equal to n. Why I am doing this? Because I do not want to lose the originality of the number after this wholesome thing are done. Because after this while loop particular thing is done, if you will be trying to find out the value of n, it will be particularly 0. Because when n has become 0, then only this loop got terminated. So that is why for safety purpose, I am storing the original value of n in n1. Now after I will be checking, here I will be writing what? I will be taking simply n1. Let me store this again. Let me store this n1 again. Let me take n2 is equal to n1. Okay, so now let me do changes. N is already changed, n1. Okay, if I will be changing n1, then it will be okay. N1 is not equal to 0. So here I need to take another variable. Just a moment. So here I need to take another variable. Let me take int z, not z, int b. Okay, here I will be storing the two separate parts of the digit. So b is equal to n1 modulus 100. Okay, so here I need to initialize another s to store the sum of the digits. S is equal to 0. Here s is storing b. Now my n1 is becoming n1 divided by 100. So by this what will happen? S will be storing, just a moment, s is equal to s plus b has to be done. The sum of those double digits, whatever number that was taken, that will be stored here by adding up here. And after this the work is not completed. See, the question is something different. We need to store. Do I need to directly store the digits? Okay, I need to check after. See, in my other while loop, what I had done, I had added this 2 and I have found out 55, but that's not the complete thing. Here after my s, after this I need to check if I'm finding s into s is equal to my original number, because n2 is only the place where I have not changed my number, while n1 is already changed, the place of n1 is already changed, the place of n is already changed. So here I am I have taken n2 where I have not done any change. So if I will be finding the square of the number whatever I have found out, that is equal to the original number. So here I can write system.out.println whatever the question is. You will be understanding it better if you will be keeping the question at one side and you will be observing whatever I have written. That is the best way. So it is said to be a tech number, right? Acha, a tech number. Tech number. Okay. Else you will be writing whatever things are needed. So here I could find due to creation of this kind of mesh, I know the student has checked very particularly whether the number is even or not, but due to lots of cutting, I could think here actually the things are done perfectly. But see, here the student has stored the remainder of the number, but that's not correct. It has to store, what has it done? But the the student should have stored the quotient of the number, yes or no, so that next time the quotient of the number will become the number. I could find this is the incorrect part, but this is somehow the correct part. This has to be 100, no? This has to be 100. Okay, this part is correct. So I could find at most 7 to 8 marks from the 15 will be the mark that will be given by the by the examiner for this program that you have done. Only some of the marks will be given, so that you have declared variable, you have declared a write package, you have declared scanner class, but it will be disappointing the examiner. Okay, so there are some other parts of this particular program as well. So as this particular video is itself has become around 22 to 22 minutes, so the part 2 will be uploaded just right after this. Okay, so till then I think you have already understood how a particular examiner will be checking the papers. So just wait for the part 2. In part 2 also I will be breaking down how the other parts of the number based program the teacher will be checking in the board examination. Okay, thank you for watching this particular video. Prepare very properly for your upcoming board examination, and bye bye.